Students, now we shall see the Pythagoras theorem. So, have you heard about the mathematician Pythagoras? So, who is lived in Greece? Students, so this is the photo of the Pythagoras. You have seen these photos in your early classes. So his theorem was called as Pythagoras theorem. So observe his photo. So here is a little information regarding the Pythagoras. So Pythagoras, he lived in 569, between 569 and 479 BC. So in the Greece. So he is a great mathematician. Pythagoras, a pupil of Thales, is perhaps best known for the theorem on right angled triangle, which bears his name. He helped to develop the study of geometry in logical way by using undefined terms such as definitions, postulates, and logical deductions. The influence of his school in the fields of mathematics, science, music, religion, and philosophy is apparent even today. Students, his theorem is very important in our day-to-day life. So he proved the theorem by using a right angled triangle. Right angled triangle. So this is all about a small information about the Pythagoras. Now students, we will see the theorem which he proved and the applications of the Pythagoras theorem. Students, today we shall see the continued part of the triangles. So in the previous classes we have discussed about the similarity of the triangles, and also we have proved the three theorems. First one is Thales theorem, another one is angle criteria theorem, and third one is area and similar triangles. And also we have simplified the problems on those theorems. So now I am going to tell you one of the important theorem in this class, that is Pythagoras theorem. Pythagoras theorem. So all of you heard the name of the Pythagoras, the famous mathematician who lived in Greece. So I think you have seen the photo and the biography of Pythagoras. Students, so there is a very useful applications of this Pythagoras theorem we are going to use in the construction of the buildings or by plotting the towers. Constructions of the buildings, plotting the towers, so finding the heights of the any objects, finding the heights of the objects, and also another important thing is we are going to use this Pythagoras theorem in the other part of the mathematics, that is in trigonometry. The next part you will study the trigonometry also here. So for the trigonometry also we need the Pythagoras theorem. So therefore, before going to prove the Pythagoras theorem, students, first we will perfect in the right angle triangle, because this Pythagoras theorem holds good only for the right angle triangle. So therefore we will see the right angle triangle in detail, the properties of the right angle triangle in detail. Students, you know that, so right angle triangle means it is a triangle in which any one of the angle is equal to 90 degree. Any one of the angle is equal to 90 degree. Observe here, I am drawing a right angle triangle. Name it as ABC. Student, here in triangle ABC, if you observe, angle B is 90 degree. The value of angle B is 90 degree. So therefore it is a right angle triangle. Right angle triangle means in a triangle, if any one of the angle is equal to 90 degree, so it is called as a right angled triangle. So now students, we shall see the properties. So in a right angle triangle, observe here, so this is very important to prove the Pythagoras theorem and also the problems on the Pythagoras theorem. Angle B is 90 degree. So the side which is opposite to the right angle, is called as hypotenuse. Hypotenuse means the side which is opposite to the right angle is called as hypotenuse. Therefore, students, in the given figure, AC is the hypotenuse. Okay, students. So other two sides, AB and BC. So AC is called as hypotenuse. AB and BC are called as sides which contains the right angle. AB and BC are the sides which contains the right angle. Now, if you observe or measure all the three sides of the right angle triangle, all the three sides of the right angle triangle, hypotenuse is the largest side. In a right angle triangle. Okay, so we will write in a triangle ABC. Angle B is equal to 90 degree. So angle B is equal to 90 degree. So therefore, we call this ABC as a right angle triangle, and it is written as a triangle symbol. So in that we write right angle. So this is called as, we will write the right angle triangle in this way. We will write the right angle triangle. So this is simply we will write the triangle symbol. So for the right angle triangle, we use this symbol. So this symbol indicates is a right angle triangle. So AC is called as hypotenuse. AC is called as hypotenuse. AC is called as hypotenuse, and it is and it is the biggest side, or you call largest side. It is the largest side. It is the largest side. Okay, students. So now we shall see the statement which is given by the Pythagoras and also proof of the theorem, Pythagoras theorem. Now students, we will see the Pythagoras theorem. Pythagoras theorem, statement of the Pythagoras theorem is, in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. You have to remember this. So in the examination, they will not give the statement for the proof. They will ask, state and prove Pythagoras theorem. So therefore, we have to remember the statement of the Pythagoras theorem. So it states that in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Okay, students. So we will prove the theorem step by step. So this is the statement of the Pythagoras theorem. In a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Students, so the first step of this proving the theorem is, we have to draw the rough sketch. So here the statement itself gives that we have to take the right angled triangle. So therefore, I have drawn the right angled triangle here. So ABC is a right angled triangle where B is the right angle. That means angle B is equal to 90 degree. So in the data, we will write in a right angled triangle ABC, angle ABC equals 90 degree, or simply you can write angle B equals 90 degree. So now to prove the square on the hypotenuse. So which is the hypotenuse in a right angle triangle? Yes, the side which is opposite to the right angle is called as the hypotenuse. Here is AC. Square on the hypotenuse. That means, so AC square is equal to sum of the squares on the other two sides. So AC square equals AB square plus BC square. That we are going to prove. AB square plus BC square equals AC square, or you can write AC square is equal to AB square plus BC square. So this data is insufficient to prove the Pythagoras theorem. So therefore, here we have to make some alter in the figure. So that is, we have to draw some construction. That means we have to draw the perpendicular to AC from B. So now I am going to draw the perpendicular from the vertex B to the side AC. To the side AC. Call this as point D. So this D is perpendicular to AC. That means it makes a right angle on either side. So now students, the next step is proof. So if you observe this triangle, right angle triangle ABC, there are three triangles are there. There are three triangles are there. So just we are going to compare. We are going to compare the two triangles at a time. The two triangles at a time. So if we show that those two pair of triangles are similar, then we can easily prove the theorem. So now we shall see which are those triangles. Observe here, students, ABC is the triangle which is drawn in the first, which is already exists from the starting. So that is ABC is one triangle which is larger triangle. So if we draw when we draw the perpendicular BD, so it is divided into two triangles. There are ABD, the above triangle, and the below triangle BDC. So in proof, we are going to comparing the two triangles. That means first time ABC. So ABC with ABD, and another time ABC with BDC. So just we will move on to the proof. Now students, in right angle triangle ABC and AD. In right angle triangle ABC and ABD. So observe. So angle ABC is, that means B is 90 degree. Similarly, in the above triangle ADB, so this BDA or ADB will be equal to 90 degree. So here in the right angle triangle ABC, angle B is equal to 90 degree or ABC is equal to 90 degree. So in the right angle triangle ABD, so this ADB is equal to 90 degree. So now, if you observe angle BAC or simply A. So that means this is a common angle for both the triangles. This is a common angle for both the triangles. Therefore, we can write for the triangle ABC, angle BAC is equal to angle BAD. Is a common angle. So in a triangle, if two angles of one triangle are equal to the corresponding angles of another triangle, then we can write, or we can understood. It is understood that the third corresponding angles are also equal. So therefore, by angle criteria, so these two triangles are similar. So therefore, we can write right angle triangle ABC is similar to right angle triangle ADB. So now if they are similar, then their corresponding sides of ratios, that is AB by AD. So AB by AD is equal to, another one is hypotenuse AC. So AC is the hypotenuse here because it is opposite to the side B. Similarly, AB is the hypotenuse for angle D in this triangle. So AB is the hypotenuse for the triangle ADB, which is opposite to this ADB angle. Therefore, AB by AD equals AC by AB. Now cross multiply this to the numerator. So we get AB into AB equals AB square equals AC into AD. AB square equals AC into AD. Call this as an equation number 1. So now students, similarly as we have done in the first part of the proof, now we are going to compare the two triangles under pair ABC with BDC. ABC with BDC. So in a rectangle triangle ABC and rectangle triangle BDC. In the same way, write the angles. Angle ABC. So in a right angle triangle ABC, angle ABC, this angle B is equal to angle BDC or CDB, because these two are equal to 90 degree. So data, first one is from the data and another one is we have constructed B, so BD perpendicular to AC. Then another angle is in a right angle triangle ABC, BCA, this angle BCA, this angle, and in a right angle triangle BDC, again we have this angle C. That means angle C is common for both ABC triangle and BDC right angle triangle. So therefore we will write angle ACB is equal to angle DCB, which is a common for both the triangles. So therefore we will, if two corresponding angles are equal to two angles of one triangle are equal to the corresponding angles of another triangle, we understood that the third angle is also equal. So therefore, by using angle criteria, right angle triangle ABC is similar to right angle triangle BDC. So once again, so if we write the ratio of the corresponding sides, BC by DC. So here BC by DC is equal to, again here also we are going to take the hypotenuse AC, which is opposite to the right angle, AC by BC. So this is the BC is the opposite to this BDC right angle. BC is the side hypotenuse, it is called as hypotenuse because it is opposite to the angle BDC. Now cross multiply this. We will get BC into BC is BC square equals AC into BC. BC square equals BC into BC. All as an equation number 2. So now adding equation 1 and 2. We add equation 1 and 2. So in the LHS AB square, here it is BC square. AB square plus here we have to add the LHS. Therefore AB square plus BC square equals. So in the equation number 1, RHS AC into AD. AC into AD. We have to add the RHS also. Therefore plus sign is there. We have to put the plus sign plus AC into DC. So keep the LHS as it is and simplify the RHS. We will get. So observe here, in both the cases AC is common. So therefore, if you take the AC as a common, AC into AD plus DC, the remaining is AD plus DC. So if you observe from the figure, if you observe AD into DC, if we add the length of AD plus DC, we will get the length of AC. So therefore, in place of AD into DC, we will write again AC. Therefore, if you multiply AC into AC is AC square. Therefore, AB square plus BC square equals AC square, and hence the proof. Okay, students. So this is how we have proved the Pythagoras theorem. So this is an important theorem for the examination purpose also. So for the our life purpose also. Students, we shall see in the next class. Okay. Students, before going to close off this class, you should have first just you glance the theorem clearly. The statement is the statement, and is the diagram for that, figure for that. What is the data? This to prove, and construction proof. We have to divide this proof into two parts. Divide this proof into two parts. First compare ABC and triangle ADB, and then triangle ABC and BDC. Next step is, last step is, just we are add the result which is obtained from 1 and 2. Okay, students. So, and try to remember the theorem, or visualize or picturize in your mind. See in the next class.